Thanks a lot. Thanks so much for coming. This is a joint with Beatrice and Elyashiv. And the motivation for our project, simple observation, that when markets price firms, they do so using information provided by the firm as well as from external sources. And the interest today is what happens when those external sources are potentially unreliable. Okay. So specifically what we'll be doing is modifying a classic voluntary verifiable disclosure model. If you're not familiar with that, I'm trying to make this as self-contained as I can. We're going to have a manager. The manager is going to potentially have some information that they can disclose, or they can remain silent. The probability that they'll be able to disclose is P. And then the interest will be in who's going to disclose and when. And so a typical equilibrium in this model involves a threshold. Okay. And the managers who can disclose are going to whenever the value is above that threshold. Okay, and they're going to remain silent whenever it's below the threshold. Okay, if they don't have any news they can't disclose, then they'll just remain silent. And so the market will look at the behavior and they'll form a conditional expectation. Now, so in that case, the price will be a number, but once we add external sources, we're going to have the market price be a function of the signal. Okay, and so we'll be interested in looking at that market price function. Now, our interest is going to be specifically in what happens when this external news has unclear informativeness. So, my co-authors are in accounting. They have many fun stories about cases where, there was potentially unreliable information. Hopefully, in the interest of time, you'll just believe me that sometimes you might see a tweet or some kind of report, and it's not clear whether that thing is accurate or not. And in our model, we're going to be thinking about cases where the disclosure decision can be before the news arrives, or potentially after. So in the first case, it'll be preemptive disclosure. In the second case, it'll be late disclosure. And so the thesis of our project and the talk, and I'll come back to this over and over again, is that when you don't know how informative this signal is, then this external news has to be taken with a grain of salt. Okay, and what our contribution is to be studying the implications of this idea and disclosure. So there's going to be two questions of interest. The first is, what's the impact on the incentives for managers to disclose? And so in the case of early disclosure, we'll show that fewer managers disclose. So this information is going to crowd out disclosure. For late disclosure, it's going to be ambiguous, but there's going to be two regions. And then in one of the regions, the lower regions, signals would not be disclosed whenever they're lower than firm value, and vice versa for the higher region. There'll be a picture later with it a little bigger. I think the more striking result is the second one, which is the implications on market prices. This is kind of most of what I'll be focusing on today, which is that you can be in a situation where you have a more favorable, the signal becomes more favorable, and yet the price becomes lower. Okay, and so we'll show you that generally this model is going to feature this kind of discontinuous drop in the price around the disclosure threshold. That's our main observation. And the brief intuition for this is that it's just this grain of salt idea. These are the signals that are more likely to be noise, and so they're discounted. Okay, but there's a lot of subtlety. It's not. I think maybe it sounds too obvious for that intuition. We'll be talking about it. Okay, so here's the model. We're going to have a firm with value belonging to this interval. The value is going to have a prior distribution G with expectation mu. We're going to need this G to be strictly log concave. What I really need is something else. What I really need is the conditional expectation of V, given that V is less than or equal to V bar, to be increasing in V bar at a rate less than 1. Okay, strict log concavity is going to ensure that that's going to hold in every case I care about. Okay. So there's going to be an external signal. And in today's talk, I'm going to be looking at a very particular information structure. We have thought a lot about relaxing it. I can tell you everything I know about that offline. So there's going to be, the signal is going to be equal to the value with probability Q. Okay, otherwise, it's just going to be an independent draw from the same distribution as V. Okay, so this is this truth or noise information structure. It's truth with probability Q. It's noise, complete noise, just this independent draw from the same distribution with probability 1 minus Q. Now, the one comparison I'll want to do on one slide will be the comparison to the case where I know the distribution and I know it has some noise. Okay, so this is truth or noise. And we'll be wanting to compare it to truth with noise. In particular, I'll be comparing to the benchmark where this signal has a density conditional on V satisfying the monotone likelihood ratio property. Sort of a standard property. If you don't remember it, it's right there. It's going to be satisfied by most cases that you would be interested in. Okay, so the firm is gonna the manager is gonna learn the value with probability P, and if she's informed, she can voluntarily disclose it. We'll be considering the cases where this is before or after the external signal arrives. I'm gonna assume that if the manager is indifferent, they're going to stay silent. That's a refinement. I can talk about what happens when that's relaxed as well. So I want to emphasize that whether the manager is informed or not is going to be independent of the signal accuracy. Okay, but in the model, these are going to be endogenous to the third point. That's going to be one of the themes we talk about. And so the risk neutral investors are going to look at everything that happened. They're going to price the firm based on the conditional expectation, and the manager is going to be maximizing market price. So there's a picture, information endowment. We'll be looking at the manager will learn the value or not. There will be a disclosure decision either before the external signal arrives or after, and then the market price is one. Okay, so the first benchmark is when there is no external signal. Okay, so there's going to be two benchmarks I want to walk through. The first is when there's no external signal. It's equivalent, and I want to emphasize this, it's equivalent to the case where the external signal is known to be noise. In that case, this is just the Dye model from 1980. So if you didn't know the Dye model, now you know the Dye model. What's going to happen is that the firm is going to withhold a value whenever it's below a threshold, and the threshold is going to satisfy this indifference condition, that when the manager can make the disclosure, well, if they disclose, they get the price is equal to the value. If they're silent, then you form the conditional expectation. Okay, and so the threshold is going to have to make those two expressions equal. Okay, and so this gets out of the standard unraveling results because when the investors see non-disclosure, they don't know whether the manager didn't disclose because she was uninformed or because she had news and it was pretty bad. And so I want to emphasize this is the definition of VB, and so I'll be coming back to VB throughout the talk. That's an important term for our analysis. Okay, so the second case I want to talk about is what we discussed before, which is when this S has no noise, which satisfies MLRP. This was studied in similar to a model studied in past work. The fact that they so I want to emphasize this is the assumption that the signal has known informativeness, right? And so a Trier, DeMarzo, Kramer studied a setting like this. It's a little bit subtle to see that they're making this assumption, but they say but the specific assumption they make is that the accuracy of the signal given a value is deterministic, and so that's kind of the same as knowing the informativeness. And we know from Milgram that if you have MLRP, it actually doesn't matter what the prior distribution over V is, the higher signals are always going to be higher. So what that means is no matter what the equilibrium is, it doesn't matter. You're going to have the price is going to be increasing in the signal whenever this informativeness is known. And so we're going to break that result, and we're going to break it using the fact that the belief about the distribution will be changing. Okay. That leads to other complications, but we can handle. Okay, so I want to talk about the joint updating of the beliefs about the informativeness, as well as whether the manager is informed, has the information. And so for now, when I want to walk through this, I want to treat the manager behavior as exogenous, and later we'll talk about endogenizing it. So the manager is just passive, and they're going to follow some specific disclosure strategy where they disclose above a threshold V hat. And then later we'll think about what V hats make sense. Okay? Yes.
I'm sure you said it, but I'm not sure. Are you comparing two models where either we have early or we have late disclosure, or can the manager choose to disclose either early or late in the same?
Right. One or the other. If you could do both in this model, if you could do both, you would always disclose them.
Okay.
In the previous version, we had costs. Yeah.
So now we're looking at later, I guess.
This is kind of just any either early or late. It's just the manager is disclosing above some threshold we have. The difference between early and late is whether that threshold can depend on the signals. That's going to be the difference. So very good. So given that there's I'm going to be interested in looking at the price. So the price is going to depend on the joint probability that the signal is the value itself, as well as the probability that the event that the manager is informed. Okay. And really the only idea of the paper is that if you look at signals that are above the disclosure threshold, it's impossible that the manager is informed and the signal is accurate. That joint event is completely impossible because if the signal was, if the manager's value was actually above the threshold and they were informed, they would have disclosed it. So if you look at what happens in non-disclosure, well, that has to be 0. Okay, and so you can, what I plotted here is the probability that the signal is true when the and the manager is informed, and you can see it's positive below the threshold and it jumps to 0, drops to 0 at the threshold. Correspondingly, all the other beliefs are going to jump up, right? They get kind of proportionally more minutes. Okay, and so now when I write down the price, there's basically going to be 2 different cases I have to consider. So the first case is when the accurate signals are not disclosed, okay? And in that case, the first expression is what I have for the non-disclosure price. You'll notice that this is a convex combination between the signal S and what the price would have been if the signal was noise. Right, so it's going to be a convex combination between those 2 things. Okay, and the point is that if the market starts conjecturing that accurate signals are disclosed, then less weight is going to go on the signal S. Okay, and so you can see that from this extra 1 minus p term in the second expression. Right, so the first expression is the non-disclosure price if accurate signals are disclosed. The second is the non-disclosure price if they're not. The first one is not disclosed. The second one is if they are disclosed. And so this is true, kind of coming back to the Young's question. This is true both for early and late disclosure. The difference is whether this v hat can vary with this. So I want to talk about the price function for early disclosure, again, assuming this exogenous strategy. And based on this previous analysis, there are 3 cases that we have to consider. So and so these are the 3 different plots you can have for exogenous strategies. So I want to talk about the middle one first. So in the middle one, the middle case is what happens when the threshold is equal to the die threshold, the same when there's when the signal is known to be noise. Okay, and so in that case, the difference between signals above the threshold and signals below the threshold, the difference is that the amount of weight that's put on the signal itself versus on what the price would be if the signal was noise. Okay, and the point is that if the threshold is equal to the die threshold, then those 2 expressions are the same, and so you're just kind of shifting mass between 2 things that are the same. Okay, and so that's why you have the prices continuous in the middle case. It has a kink because above the threshold, the prices are less responsive to the signal. Okay, now in the left figure, that's the case where the threshold is below the die, the die benchmark. And for that, I want you to remember that I have this assumption that ensures that the conditional expectation of v given that it's less than v hat has a slope less than 1 in v hat. Okay, so if you are looking at a threshold below this signal, below VB, then in that case, if you had a signal equal to the threshold, well, now that signal is less than the expectation given silence. Okay, because that slope is less than 1. And so that's why you have a jump up in the left picture and you have a jump down in the right picture, because that's sort of the case where the threshold is above. Okay, so we have these 3 different cases, and our result is that the first 2 can't happen. That the only thing that can happen is for a jump down. So our result is that there's a unique disclosure equilibrium, and that the disclosure threshold is going to be above the die threshold, and hence we're going to have induced crowding out disclosure. And in particular, we have this non-monotonicity in the disclosure price at v hat. So I should emphasize I've plotted here the expected price, not the price, the expected price. And so at the disclosure threshold, you can see that's when the red line intersects the blue line. And for managers whose value is below the threshold, the expected value from silence is higher than the expected value from disclosure. And so they're silent, and then above the threshold, it jumps down and they start disclosing. There's a very nice, I like this argument for why you can't have the first case. So if you have a manager who's just above the threshold in the left picture, the price is jumping up. Right, so why is the price jumping up? The price is jumping up because all of a sudden the market conjectures that those managers are disclosing. But if you had a jump up in the price, then those managers who are starting to disclose, they would actually like to stop disclosing. So that's sort of a simple argument that you can't have the left picture. That's not a proof at all. The actual proof is way more complicated, but I like that intuition. Okay, so I have a little bit of time. So in the case of late disclosure, this is what the graph looks like. So there's going to be, again, a unique equilibrium. And disclosure, and there's going to be a function of the signal which we call VL of S, and so disclosure is going to occur whenever V is greater than VL of S. Okay, and you'll see that there's a kink at the VB at the die threshold because that's sort of when the managers with informative signals start disclosing. Okay, so that's sort of the reason why you have this kink is explained by this grain of salt updating. And what I want to point out is that you'll have this region here where when the signal is less than VB, you'll generally have a region where some managers will not disclose, even though their value is higher than the signal. So, once you think about it, it's kind of obvious, but it's sort of a nice, for applications, kind of a nice, it tells a story for why you might not have managers disclosing, even though their own information is actually better than what's kind of out there in the public. So great. So that's what I have. So we have a model of dynamic disclosure, which adds uncertainty over signal accuracy or informativeness. We think this is a very relevant feature as it's often very difficult to determine, increasingly difficult to determine signal accuracies. And we identified some subtleties that emerge given this possibility. So the key takeaways are first, in the case of early disclosure, we have non-monotonic prices. In the case of late disclosures, we have this nice story for why firms might not correct favorable signals. We currently have some generalizations beyond truth or noise. One thing I want to, and the basic punchline is that our results are going to be maintained as long as we're close enough to truth or noise. Obviously, the close enough is doing enormous lifting there, but on the other hand, we kind of know we didn't expect our results to be maintained without the qualifier. Right? That was the whole point. If we knew that it's truth or noise, I mean, the Milgram result is just so powerful, we would have expected to have monotonic prices. But that's actually, but it's pretty tricky to do. For one, just one kind of like taste of the difficulties is that we don't have any kind of simple conditions which ensure that the slope of the price function is less than 1, which is kind of an important property that we need for all of our analysis. And in the generalization, we don't have that. So we have ways of getting around the need to do that, but happy to talk about that.